notes for you today. So you are taking these in your notebooks. So what we need to remember, when we have vertical shifts, it's when you have a function with a number added or subtracted on the end. So whatever our function is, and then we tack something on the end, plus 5 or minus 4. If we add, how does that move our graph? Up. If we subtract, that moves our graph down. So what I always tell people, anything on the outside changes your y value, and it does what it says. So outside, it's not like in the square root or in the parentheses. It's on the end. It'll change your y value exactly how it says. Adding goes up, subtracting goes down. It's like adding or subtracting to your y values. Horizontal shifts happen inside our function. So it's under the square root or inside the parenthesis. And these actually do the opposite of what you think. So when you add to your x value, it will move it to the left in the negative direction. When you subtract, it will go to the right. So anything on the inside changes the x, it does the opposite of what it says. So, inside is x, does the opposite. Adding moves it in the negative direction, subtracting moves it in the positive direction. Outside is y, does what it says. Adding goes up, subtracting goes down. So we need to know these because we don't have a graphing calculator, so it's not like you can just plug them in your calculator and double check yourself. I am going to expect exact points. When we did our parent functions, those basic ones, how many points did I tell you? 3, minimum of 3. That is still the case. So what I'm going to tell you on any of these is I want the parent function with a minimum of 3 exact points, and then the final graph with a minimum of 3 exact points. When we draw these, our parent function, that original function, we are going to draw this as a dashed line, and our final one will be a solid line. If you do it that way, you don't have to label which is which. If you don't, then I expect labels to know which one's your parent function, which one's your final transformation. So you're welcome to color code it or whatever you prefer, but I need to be able to tell the difference between the two graphs on your paper. All right, let's try one. So I'm sorry I didn't print graph paper for you today, so you can draw a graph. Our parent function is x cubed. So if I'm graphing x cubed, minimum of 3 exact points, how do we get those exact points? T-chart. Yep, just plug them in. So I don't care if you don't want to write down your t-chart, but you have to be able to think through it. So if I put in 0, 0 to the third is 1 to the third, negative 1 to the third. Okay, if that's not enough for you, you can always do more. If I did 2 to the third, so 2, 8. Negative 2 to the third would be negative 2, negative 8. So 0, 1, and negative 1, that's your 3 points, but maybe wasn't enough to clearly see your graph, so if you don't remember what your x cubed looks like, you need more points to get it for sure. So x cubed is that chair. This is my original, so we are doing that as our dashed function. Now, our transformation. We are doing x cubed plus 4. Now, could you make a t-chart for this? Could you? Yeah, you can make a t-chart for anything, but it's not always the fastest option. If you know our transformations, there's a faster way. It's originally an x cubed, so it keeps the same shape. What would this plus 4 do to our graph? Up 4. We know it's up because it's on the outside. I took my cube and I just added something on the end. Outside is y and it does what it says. So essentially I take these points that I put on my graph and I move each one of them up 4. So I take my 0, 0. Up 4. My 1, 1. Up 4. Negative 1, negative 1. Up 4. So we get the exact same thing shifted up. Does everyone understand how I got that? I want you guys to do one. So I'm going to give you a function and a transformation. You need to graph both. Original function dash, final one solid, minimum of 3 points on each. Something that I am noticing on a lot of your papers. You did absolute value of x. Absolute value of 0 is? Absolute value of 1 is? Absolute value of negative 1? Okay, if you have this, do I actually know where your points are? What's wrong with that? Yeah, we don't have any tick marks. If you have dots but no tick marks on your x and y axis, that point actually means nothing. So you need to show this is x is 1, y is 1, 2, 2. You need to have those tick marks on your x and y axis. Otherwise, that doesn't tell me where your point is. So remember, absolute value is the v. Make sure it looks like a v and not a u. Does everyone understand what I mean about those tick marks? Probably about half of you are doing it that way without any tick marks, so make sure you add those in. All right, what will this minus 2 do to my graph? All right, it's on the outside, it's not a part of the absolute value. So again, I can't just go down here and put a dot. That doesn't show me where it is. So we have to say, okay, now I'm going to take each of those points down to. It's the same shape, just move the entire thing down. Any questions about that? All right, next one, I am going to give you a graph and I want to see if we can write the equation for it. All right, if I look at A, that one should look pretty familiar. What is the parent function? Right, f of x or y equals, it doesn't matter which. Now I know my original absolute value looks like this, so how did my graph get moved? Down 2, isn't that the exact one we just graphed? So that, how would I show in my equation that it went down to? Okay. Write the equation for b. Everybody jot it down on your paper. What would be the equation for graph? And I know that because of the v. But this time it took the original absolute value and it went up 1. So it has a plus 1 on the end. Any questions there? Let's do some more. Okay, my original function, g of x is equal to x squared. What does x squared look like? So 0 squared is 0, 1 squared is 1. If you wanted 2 squared is 4. Negative 1 squared is 1. Negative 2 squared is 4. Make sure you have tick marks on your axes. So that one is like a U. It's curved at the bottom. Alright, then the first one, g of x minus 3. We know from function notation that just means we're replacing the x with x minus 3. So that's x minus 3 squared. So that's inside because it's in my parentheses. I told you inside changes x and it does the opposite of what it says. So if I am subtracting 3, it will move it which way? Direction. So I'm taking each of my points and moving them to the right 3. There's my g of x minus 3. G of x plus 2. So that means x plus 2 squared. What will that do to my graph? Left 2. Inside is x, does the opposite of what it says. So we move it in the negative direction. We're doing the original, left 2. I'm going to put a couple pictures up here and I want you guys to write the equation that goes with them. Are there any questions over this one so far? I want you guys to write the equations for each of these. What's the parent function for both of these?
Absolute value of x.
So you can call them y equals, you could call it f of x, g of x, whatever you want to call it. So we have the absolute value of x. This one moved which way? Right? So if it's moving left or right, we know it's on the inside, and it does the opposite. So since it moved in the positive direction, so it's the absolute value of x minus 4. Alright, B, how did this graph move? So we think it's the absolute value, left and right is on the inside, it moved in the negative direction, so we do the opposite, so it's the absolute value of x plus 2. Looked like we did pretty well with those. Are there any questions there? Let's do some where I have them mixed together, and you have to decide if it's up, down, left, and right. So on A, x squared plus 1, what is my parent function? Just the x squared, so the quadratic. 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1, 1, negative 2, 4. Does everyone know how I get those points? What's my transformation this time? So, is the one inside or outside? Outside. Outside changes y and it does what it says. So this would move my graph up 1. So I take each of those points and slide them up 1. And so that would be my final graph. Again, if you do the original dashed and the final one solid, you don't have to label which is which. Otherwise, you do. B, parent function is still the quadratic, the x squared. So the same parent, 0, 0, 1, 1, 2, 4, 1, 1, negative 2, 4. Okay, this time my 1 is on the inside. Inside changes x and it does the opposite. So subtracting would move it right 1. Okay, so slide each of your points to the right 1. C, what's the parent function? Still parabola because I have the x squared, so same as the last two examples. If you wanted to do these on the same graph, you can. You just have to label which is which. Okay, 3 is inside. Inside changes x and does the opposite. So adding 3 will move my graph. So take each point left 3. Final one like this. F of x equals x cubed minus 4. What's the parent function?
The chair.
X cubed. The chair. 0 cubed is 0. 1 cubed is 1. If you need it, 2 cubed is 8. 1 is 1, negative 2, negative 8. Okay, transformation. Is a 4 inside or outside? Outside. Outside changes y and it does what it says. So what's going to happen to my graph? Down 4. So each of these points, down 4. Are we having any trouble with this? You guys remember doing this in the past? I have 2 more slides that I would like to go through. All the problems we've done so far have only had one transformation, but there is actually not a limit on how many things we can do, so we might have multiple. So I'd like to try a couple examples where we have more than one transformation at a time and make sure that we were okay with those. All right, so on A, what is my parent function? Absolute value, the V. So absolute value of 0 is 0. 1, 1. 2, 2. Negative 1, 1. Negative 2, 2. Okay, tell me first of all what the transformations would be. So what will this plus 2 do to my graph? Left 2. And what's the minus 6 going to do? So I'm taking every point, moving it left 2 and down 6. My scale wasn't perfect. Right, you guys try B for me. With the parent function, I want you to tell me what the transformation is, and I want you to... What's the parent function? 0 cubed is 0. 1 cubed is 1. Negative 1, negative 1. You could do 2, 8, negative 2, negative 8 if you wanted more points. If you weren't sure what it looked like. What's the minus 1 do? And the plus 4? Right 1. Is that okay? Last question I want to look at is finding domains and ranges. So I'm going to give you some equations and ask for domain and range. Your homework tonight is going to do the same thing. You'll notice I don't say that you have to draw a graph in a parent function, but it might be helpful if you're trying to find domain and range. Okay, so if I said we have x minus 1 squared plus 2. Okay, totally up to you. Graph isn't required, so if you look at this and you know the domain and range, great. You're good to go. Do you know what the domain of every quadratic is? Yeah, if you think about a parabola, it keeps getting wider and wider. Does anyone know what the range would be from that? So if you're familiar with the graphs and transformations, you might be able to look at it and tell. If you can't, that's fine. Just draw yourself a rough sketch. Now this one, am I even checking your graph? No. So do you have to have a minimum of 3 exact points? Not really. You certainly could. You know, it's not hard to throw them on. This is my parent function, our quadratic. What happens to this graph? How does it move? Okay. So if I move it right, Then can you look at that graph and tell me what's the domain of it? Keeps getting wider, so the domain is everything. The range, we can see on the final graph, that solid one, my lowest point is 2. And then it goes up forever. So 2 to infinity, just like you guys told me before I graphed it. B. Can anyone tell me what the domain and range are before I ever graph that one? You're half right.
It will be negative infinity, positive infinity, positive. Because the chair always goes to both.
Yeah. So if you were x squared, you would have been right. This one is x cubed. So if you think about your chair, how does this one move?
Left one up to, or down to.
Down 2 and left 1. So same thing, but it's still, no matter what, that chair, it's still going up and down forever, it's still going left and right forever, so my domain and range didn't change.
So theoretically, a cube root will always be.
Yep. If your original domain and range are everything, then your transformation still will be. That
So
won't
what was
change.
the fourth root?
A fourth root would look like a skinnier parabola. Alright, let's talk about this one, a square root. We haven't done one of those today. If I did my parent function, what is the square root of 0? Okay, what's the square root of 1? Can I do 2? Okay, square root of 4 is 2. Can you do negatives? No, that would give us imaginary. So remember, your square root graph looked like this. How is this one moving? Okay. So we're going to move each of these right 2, down 3. So domain, what x's do we hit?
From 2 to infinity, and then -3.
So on those, if all I'm asking for is domain and range, graph is 100% optional. If you know, that's fine. But if you don't, that graph supports your answer. It gives you something to look at to find domain and range. Are there any questions? So there's a math Excel assignment open that I would like for everybody to get started.